The concepts of probability are at work around us all the time. Very frequently, we'll be engaged in conversation and we'll colloquially refer to the probability. You might be thinking of the weather tomorrow and thinking about there being a 50% chance that it's going to rain. So, we're all very well versed in the idea of probability. It governs the behavior of anything that's random around us. However, the formal study of probability takes all of these intuitive ideas that we have, these colloquial terms that we have that deal with chance or uncertainty, and it makes them all mathematically formal. And so when you start to study probability as a mathematical subject, really what you're going to be trying to do is take these intuitive ideas that you have, these ideas that are very familiar, and then make them rigorous. And that's what the field of probability is really doing. So when we refer to probability, we're referring to the study of randomness or uncertainty. Broadly speaking, if what we're dealing with when we are studying mathematical concepts is addressing uncertainty, addressing randomness, then we're dealing with the concept of probability. And at the heart of everything that we do with probability is this idea of randomness or uncertainty or chance. And so while chance is all around us, it's useful for us throughout the study of probability to grab a hold of examples that we can use to walk through what we actually mean by randomness or chance. And so we can envision a situation here where we have a coin. And normally with coins, we're thinking of heads and tails. On this coin here, on one side, we have this flower, and on the other side, we have this lizard. Okay, and so if we were to actually hold this coin in our hands, we could toss this coin, and there's going to be some random chance that it shows with the flower facing up, and there's going to be some random chance that it shows with the lizard facing up. And if this coin behaves the way that coins typically do in the world around us, then what we could say is that there's going to be a 50% chance that it shows a flower and a 50% chance that it shows a lizard. And this is something that, again, we're probably very comfortable talking about. And what we want to try to do is actually put meaning towards this. But the really key idea at the heart of probability, at the heart of randomness, is that even if we can quantify this uncertainty, we can say that there's a 50% chance that it shows up as a flower and a 50% chance that it shows up as a lizard. And even if we can make sense of exactly what that statement means, when we go to flip the coin, we still don't know what's going to happen. There's still going to be uncertainty there. And so really what we're going to be trying to do is develop a language around this uncertainty to allow us to quantify the ways in which we are uncertain, but we're never going to be able to remove the uncertainty from the world around us. So we're trying to understand uncertainty, but we're not going to be able to remove it. And so imagine with this coin, instead of just flipping it once, we play a game where two players are each going to flip the coin 10 different times. And if we imagine this game playing out, we might see different sequences of these coin flips, right? And so we have our first player, and they get a lizard, and then two flowers, and then two lizards, two flowers, two lizards, and then a flower, right? The second player got all lizards until their eighth throw, where they got a flower, and then two more lizards. Now, both of these are going to be possible sequences, right? Intuitively, when we're looking at this, we have this sense that player 2 was either super lucky if we want to be flipping lizards or super unlucky if we don't want to be flipping lizards, right? But there's something that feels less random about this sequence. But the important idea for us to keep in mind is that that sequence is going to be able to come up just as likely as the sequence above it's going to come up. And we can quantify exactly what we mean by just as likely there, but it's going to be a possible sequence that we can see there too. Right? And so when we have randomness, that doesn't mean we're not going to see patterns in it, doesn't mean we're not going to see repeats there. All it means is that before we flip this coin, we don't know what we're going to see. And so we're going to still try to make sense of the world, even though before we're engaging with it, we don't know exactly what it is that we are going to see. So we're thinking about probability as quantifying our randomness. We're not removing randomness. We're not getting rid of it. We are simply quantifying the randomness around us. So probability specifically is a mathematical tool that allows us to quantify this randomness. And what we mean by that is that it gives a numerical value to describe the likelihood of some event. So if there's a 50% chance that something happens, right, that's a numerical value, that 50% or 0.5. And what that 50% is saying is that somehow there's a concept of the likelihood of this event inscribed there. We can think about examples where probabilities are going to come up. sort of all over the place. So we had mentioned weather forecasts sort of off the top. If we think about sports has probabilities all over it at this point, right? So whether we're talking about strategy, the teams are actually using probabilities, or the results, right? Whether a team wins or loses, there's going to be probabilities associated there. You can think about financial or housing markets, right? The stock market has a ton of probabilities in it. If you're shopping online, they're using probabilistic algorithms to try to understand what are you going to want to buy and what should they be recommending you. The entirety of AI is sort of founded upon probability. In a medical context, right, we come in and we run some tests in the medical setting here. We can't necessarily know exactly what's going on, but we can sort of try to deal with the uncertainty of this. And the more tests we run, the less uncertainty there's going to be, but we're still in this probabilistic setting. Games of chance, right, rolling dice or gambling or playing board games, these are all going to be areas where probability is there. But even something like day-to-day interactions with your peers, right? Any time that you don't know exactly what's going to happen, we're dealing with probabilities there. Maybe you have to have a really difficult conversation with a family member or a friend, and you're worried about the chance that they react negatively, or maybe they'll react really positively to it, right? There's probabilities that we could assign there, and those might be really hard to work out, but there is still this uncertainty associated with it, right? And scientific research and experimentation is sort of founded entirely upon probabilities and probabilistic reasoning, right? So probabilities are all over the place. Again, we use them intuitively, but the idea with probability as a subject is that we can make this all very formal. Now, when we're thinking about probabilities, we're dealing with events, we're dealing with these likelihoods. What we want to know is, what do we specifically mean? So if I say that there's a 50% chance that something happens, what does that specifically mean? And there are really two ways that we typically are going to think about interpreting probabilities: the frequentist interpretation and then the Bayesian, or the subjective interpretation of probability. Now, the frequentist interpretation of probability is probably going to be the one that is most useful for dealing with an introductory probability course. It's going to be the one that comes up in probability and statistics classes most often. And when we're thinking about probability in this way, what we're thinking about is that probability represents the long-run frequency of occurrences of some event. So what do we actually mean by that? Well, let's go back to the coin flip example. And suppose you're going to be standing around and you're going to be flipping a coin over and over and over again. What would it mean if the probability that it shows the flower face is 0.5? Well, what we're saying there is that if you keep flipping the coin over and over and over and over again, then in the long run, as you've done this, millions and millions and millions of times, you should see that approximately 1/2 of the time it shows the flower, and 1/2 of the time it doesn't show the flower, right? So when we're thinking about the frequentist interpretation of probability, what we're really thinking about is, if you repeat everything over and over and over again, what proportion of the time do you witness some event? Okay. Now, this is in contrast to what we call the Bayesian interpretation of probability, where in the Bayesian interpretation of probability, probabilities are going to represent some subjective personal belief regarding an event. And so if I say there's a 50% chance that this coin comes up tails, then what I'm saying is that I have some innate belief that there's probability relates to 50%. And we can think about trying to make that slightly more formal, right? But the idea is that my belief might be different from your belief. In the frequentist worldview, everyone is going to agree on what the probabilities are. In a Bayesian worldview, people might disagree on what the probabilities are. Right? Both of them are going to have their use cases. Both of them are going to be sort of incredibly useful foundations for probabilities, but it depends on the context that we're dealing with. And so some examples that are useful for us to think through, well, how do we interpret probability here? Probability of flipping heads is 50%, right? If we're thinking in the frequentist worldview, right, then what we're saying is, if you flip coins over and over and over and over again, then 50% of the time you're going to see a head, and 50% of the time you're going to see a tails, right? The Bayesian interpretation would suggest that this is some subjective belief about the world. Now, if we think about the statement, there's a 30% chance that it rains tomorrow. Okay, so what are we actually saying? How do we interpret this in the frequentist worldview? Well, what we want to do is we want to think about being able to run the experiment over and over and over and over again. And so if we're saying this, then what we could say is, well, in the long run, if we were to be able to play out tomorrow over and over and over and over again, 30% of the time, so in 30% of days that are like tomorrow, we would see rain. Now, this is a weirder thing because, of course, we're only going to see tomorrow one time, but we can imagine, right, that we're going to actually be able to run this over and over and over and over again. And if we do, then what we should see is that 30% of the time there's actually rain. In this case, the Bayesian interpretation might be a little bit easier to wrap our heads around, where there's some subjective belief that the rain tomorrow has 30% likely. This might still be founded on our past knowledge. This might be based on some weather model that we have, but this is going to be an internal subjective belief. And so if we think that there's a 30% chance that it rains tomorrow, then what we're really saying is, well, it's more likely than not that it doesn't rain tomorrow. So maybe we're not going to bring an umbrella to work. Third example here, probability that candidate A wins the election is 67%. Now, again, this becomes a situation where the frequentist worldview is a little bit harder to wrap our minds around, but we need to sort of think about this in repeated experimentation, right? So if we were able to run the election over and over and over and over again, where each time we don't know what happened the last time, right? We just continue running the day of the election over and over and over again. What we're saying is that 67% of those repeated runs of this election are going to have candidate A winning, and in the rest, the other 33%, candidate A will not win. In the Bayesian interpretation, we're saying that we have some subjective belief that 67% likelihood that candidate A wins the election. Okay. So probabilities are all around us, right? They are going to be integral to just about every real world situation that we can deal with. And what we're going to do with the study of probability is to make all of this mathematically formal. But a really key idea is the fact that we're all bringing in our own preconceptions of what probability is. We're all used to dealing with probabilities. And so when we start to think about this as a formal mathematical tool, what we really want to be thinking about is this formal interpretation of what probability means. And most often we're going to want to think about this in the frequentist way. So probabilities are going to refer to the long run proportion of time that a particular event is worked out. And once we have that very concrete definition of what a probability actually represents, then we're going to start to be able to use math to deal with probabilities, to calculate probabilities, to quantify the uncertainty, and then to start using all of that information that we can gain to make decisions about the world or to understand the world around us better.